I forget how when I go to the Ladybug, how long it takes to record. For some reason, when I'm using this little guy, which is a wonderful device, it's kind of tricky. So let's review the bidding here real quick. What did we say this was equal to once we got it figured out? Let me see. Oh, there we go. So let me just write that out real quick. So we figured out that this was equal to 4 times the I, which we got up here. See, I we got there. Divided by, oh, I could have used that for the divided by, pi times the r bar that we calculated here, times rho, which is here, and r to the 4th, which is, this is your little r. Okay? All right. Cool beans. So now how the heck do you, how, if you're a novice at this, if this is new to you, and an equation like this just scares the bejesus out of you, which it should, but don't be afraid, it'll be okay. Here we go again. Well, let's try this again. Let's do this. Let me show you how it would be plugged into your calculator. All right, real quick. So you'd take, what you would do is you'd do parentheses twice. Do parentheses twice on calculator. Let's do this on calculator. And then what you'll do is you'll go 4 times the I that you got. Okay, the I that you got in 3B. This is from 3B. Okay. Close your parentheses. Then hit the divided key. Open a parentheses again, and then open another one. All right, because we're going to put, this is putting this on top. This is our line dividing it, and now we're going to put all these numbers that we're going to multiply out down here. So you go 3.14, or if you have a pi key, you can use it. Close the parentheses. Take your r bar that you got from, that you calculated from 4a. Okay, close that. And then put in your 1.29. Close that. And then take your r to the 4th. Now, if you've got the little arrow key, you can do your r to the 4th. But you take your little r, little r, little r, little r, and then close all that again. Okay? And that should work. That should work. I wish I had numbers that I had actually taken and figured out, but I don't. Okay. All right. So there you go. That's the way you would calculate that CO. All right. So now moving along. Now move each of your washers out to the ends of the 4 radius. Measure how far out from the center you have moved them, and that will be R2 in your calculation below. So you say R, which is your mass of the boomerang now, not the total mass. It's just the mass of the boomerang with just the rubber bands, and R squared for the paint stick. Okay? So this will be a different I. Plus 4 times your washers or your pennies times how far away they are. So here's what we're saying. You got your boomerang, right? You got your boomerang, and let me make this smaller so that we can see it better. Doesn't need to be so amplified for this. All right, there we go. Let's go a little bit smaller even. There. Oh, son of a gun. Go away. Oh yeah, I gotta click that. Ha! I'll learn how to use this machine eventually. So anyway, we're gonna put your penny there, and then put it over here like that. All right, and then measure each one of those R's. Make sure each one of those R's is the same. That would be the easiest way to do it. From the center of the penny. So you go from the center of the penny to the center of your thing. It looks like mine's about 15.5. Okay, or 0.155 meters. 0.155 meters. All right, and then that's a new I that I calculate. All right, so that's a new I that I'd have to calculate, and here it is. It would be, if we're going out, predict the new flight radius using your calculated coefficient of lift and new moment of inertia. So we're going to find a new I. All right, so on problem 6, on part 6, here's what you do. Calculate a new I. All right, the masses of your pennies haven't changed, but where they are, where their moment of inertia has. Because when they are right in the middle, they didn't have a moment of inertia really. Besides, I guess we could have added a disk. I forgot, we could have added a disk of a certain radius there. But it's okay. It doesn't matter. Actually, it won't matter a bit. All right, so you calculate the new I. Based on, you take, and your I new is going to equal 1/6 mass of boomerang without the washer, without your pennies or washers. Mass of the boomerang times its times the r squared of the paint stick. So you find that number plus the mass of each penny 4 times the, if we're going to assume that the pennies or the washers all have the same mass, 4m mass of the pennies times how far the pennies are, where this is r the pennies, and r the pennies is equal to the distance of the penny to the end, to new position. Okay, so I bet you this I is bigger than the old I. So if this I is bigger, I wonder what's going to happen to the radius. Look at the equation. What happened? What'll happen? And we're going to use the CL that we computed. Ooh, let's make that bigger so we can see what the heck's going on. Make that C. If we make this guy bigger, or make this I bigger, I wonder what's going to happen to the radius. Make a prediction. All right. And then you're going to go find your 3 R's again. Measure 1 plus measurement 2. This is your radius after you throw it. Measure 3, and you'll write down your predicted here. All right, this is the ones you predicted. Now, if this I gets bigger and CL stays the same, pi is the same, R the fourth is still the same, rho is still the same, everything down here is still the same, and this I gets bigger, I'm hoping that it comes out bigger, and then is equal to M1 plus M2 plus your measurement 3 divided by 3, and you'll see what. All right, so now see if it's close to what you predicted up above, and list 2 things that might compensate for this error. Okay, I mean, yeah, some of our measurements are a little bit goofy. We're going to have to take and all that kind of stuff. Okay, have fun with this. Please do not hesitate to email me, come see me, set up an appointment if you're going to have issues. All right, if this is going to be too difficult. I don't think it will be. I mean, it's a simple. Putting the thing together is pretty simple, but doing this worksheet, this is good stuff. All right, out here. Have fun with this. Have a great summer, and all of this will be graded soon. I mean, you'll see your grade by May, no later than May 13th. Okay, and this will be due on May 6th, which is what you wanted to know right up front. So I'll make sure I put that on there.